So a couple neat things occur when you talk about similar figures that are formed from right triangles. So in this figure here, we say that altitude CD, remember an altitude is a segment that joins the vertex of a triangle perpendicular to the opposite side. So altitude CD is drawn to hypotenuse AB. And the question is, are any of these triangles similar? First of all, do you see three different triangles? Are any of them similar to each other? Is the left one similar to the right one? Is the right one similar to the big one? Well, let's think about this for a moment. So I know that I have a 90-degree angle there, there, and there. So I know I've got each triangle contains one 90-degree angle. Now, I don't really know how big the other two angles are, but let's just play with some numbers for a minute. Let's say that this angle here is 40 degrees. Then in the big triangle here, I have a 40, I have a 90, so angle B has to be 50. Now also, in the little triangle here on this right side, we'll draw this one in red. In this red triangle here, I also have a 40 and a 90-degree angle. So this angle in here has got to be 50. And then if I think about this green triangle on the other side, then I know I have a 90 and a 50. That's got to be 40. And just as a check, 50 plus 40 make 90. So there's my right angle. So I've got three triangles whose angles are all the same. Are any of those triangles similar? Yes, they all are. And that's an awesome thing. So much so that we even write like a little conjecture rule theory about it. The altitude to the hypotenuse of a right triangle forms two triangles. They're similar to each other, and they're similar to the original triangle. So I'm going to take a minute. We're going to draw those triangles out. So here's the triangle on the left, triangle ADC. That triangle is similar to the one on the right. And notice how I'm going to draw this. I'm going to draw it in such a way that it looks like the other one. It's oriented the same way. So D is still here, but can you tell that C is going to be down there and B is up there? It's kind of like taking this triangle here and rotating it like that. Cool. And I want to do the same with the other one as well. I want to take the big triangle, and now my right angle's at C. The shorter leg is here at A. And that's going to be vertex B up there. So these are my three right triangles. Again, like the last lesson, I strongly urge you to be able to draw these out. Draw these figures. Separate your triangles. Students who separate triangles get them right much more often than students who do not. So let's play. Again, we have an altitude drawn to the hypotenuse. In this figure, side AD is 4, and side DB is 9, and we want to determine the length of side CD. Take a minute if you want, redraw, pause, I'll be waiting. Great, welcome back. So if I separate my triangles, here's triangle ADC. That has a length of 4. I'm looking for the length of CD, call it X. I'm going to take my other triangle, triangle CDB. I know that DB is 9. I'm looking for CD. And this should happen. You should have the same side written twice. Do you notice that this X here and this X here are the same sides? That's important. In these problems, you'll always have one side that repeats. There'll be a side that's shared by both triangles. So I can write this proportion now. Let's go to the triangle on the left. Maybe I'll go short leg to long leg, 4 is to X. And then the other triangle will do the same thing, short leg to long leg, X to 9. Oh no, we got X times X. That's X squared. We're good though, our algebra skills are solid. So the length of CD is equal to 6. Let's keep playing. Like I said, if you want to pause it and try it, give it a shot. All right, so this time I got side BD is 16, BC is 20. Let me draw triangles that contain those sides. The first one is going to be triangle CDB. I know that side BD is 16 and BC is 20. I want to find the length of AB, the whole base. I got to use this whole big side. I'm looking for that length there. So here's my big triangle. So here's C, A is down there, B is there. I know that BC has a length of 20. There's my BC, it's in both diagrams. And side AB I don't know. Let's write a proportion. I'll go short side to long side, 16 is to 20, as 20 is to x. When I solve this, 20 times 20 is 400, dividing by 16, I believe we get x to be 25. So the length of AB is 25. Separate those triangles, that's your friend. Let's keep going. Side AD is 8, side AC is 12, and I'm looking for the length of BD. Ooh, interesting. Because yeah, I see this triangle here, so I can redraw that and do like 8 and 12. But in this red triangle, I only know one side length. So maybe a creative person wants to do the Pythagorean theorem and find that side. Not a big fan of that. But wait a minute. Take a look at the big triangle. Look at the big triangle here. Remember I said the side's got to be in both triangles? How about that side length of 12? So if I redraw my big triangle, the 12 is here. And notice that I can call this side maybe x plus 8. Kind of like that. So we can do an equation now. We can say that 8 is to 12, as 12 is to x plus 8. Or do you want to do it a little differently? Do you want to call like this side, say y, and then do like 8 is to 12 as 12 is to y? You could do that. I think when you solve that, you're going to get y equals 18. But remember, that's not the answer, because 18 would then be the length of the whole side. So that's why if I solve the other one, I'm going to get that x is equal to 10. So again, separate those triangles. That's the way to do it. This was a question that was on a Regents exam. And it was considered to be a hard question because it was number 23. As you get going on the Regents exam, the multiple choice questions do get a little bit harder as you go through. So let's see. Triangle ABC is a right angle. Okay, so I know I have an altitude drawn to a hypotenuse. I got some similar triangles. Let's see, I know that AD is 8, AC is 12. Hey, subtraction is going to get me CD to be 4. That might help. And I want the length of side BC. Okay, I'm going to call BC X. So now, let me see if I can separate some triangles. You might be saying, oh, this looks a little weird. It's like backwards, upside down. You want to redraw it? Redraw it. That sounds cool. Let's put the C there. Let's put the D there. Put the A there. Put the B there. So then I got an X, I got a 4, I got an 8, I got a 12. So maybe we'll take the little triangle and we'll say that's a 4 and that's an X. And let's get the big triangle where that side's X and that side is 12. So now X over 4 equals 12 over X. I'm solving it, I get X squared equals 48. So X equals the square root of 48. Oh no, that's not a choice. Fear not. Here's a tip. Go to your calculator. Take the square root of 48. You're going to get like 6.923, something like that. And then go through the 4 choices and figure out which one is 6.923. Or remember that the square root of 48 can be written as the square root of 16 times the square root of 3. And the square root of 16 is 4. So that's where I'm going to get choice 2. So once again, I think this is like the 3rd video you've seen of me doing similar triangles, and the answer is separate the triangles.